It's been 6 years since Juno began orbiting Jupiter. During that time, the probe has been busy gathering incredible images and data from the gaseous giant. Veterans of this channel may remember videos I released on the mission's first and third anniversaries, but a lot has happened since then. In 2021, Juno began its extended mission beyond the initially planned 37 orbits to include flybys of Jupiter's icy inner moons, Ganymede, Europa, and eventually Io. It's been over 2 decades since Galileo visited these moons, and by studying changes in them, NASA hopes to understand what might be going on beneath their icy surfaces. And without letting the cat out of the bag too soon, that appears to be a lot. Also, thanks to the probe's powerful cameras, JunoCam, and its stellar reference unit navigation camera, Juno is taking some of the very best images we've had of these icy moons. So, with the long-running mission's end on the horizon, as NASA plans to decommission the probe in September 2025, now seems like a good time to ask, what has Juno seen? I'm Alex McColgan and you're watching Astrum. Join me today as we view the stunning highlights of Juno's extended mission and unpack the surprising discoveries that are already changing our understanding of the Jovian system. Let's start with a quick recap. Juno launched from Cape Canaveral, Florida in August 2011. After traveling for 5 years and 2.8 billion kilometers, the space probe began orbiting Jupiter on July 5, 2016. After completing most of its primary objectives, NASA extended Juno's mission and set its sights on some of Jupiter's largest moons. In total, the extended mission will add 42 orbits, or perijoves, by 2025, at the end of which, NASA will deorbit the probe by burning it up in Jupiter's atmosphere to avoid potentially contaminating those moons. This procedure is in accordance with NASA's planetary protection guidelines, but it's of special importance in Juno's case. Scientists have long wondered whether there could be life on Jupiter's inner moons, and NASA doesn't want to muddy up any future discoveries that could be made there. So, on the 7th of June 2021, Juno performed its close flybys of Ganymede, using a gravity assist to bring its orbital period from 53 days down to 43 days. Juno had already performed a distant flyby of Ganymede in 2019, when it reached a proximity of 97,000 kilometers, but this one brought the probe within just 1,000 kilometers of the moon's surface. In this photograph captured by JunoCam, you can see nearly half of Ganymede's total surface in breathtaking detail. For reference, the resolution is about 1 kilometer per pixel. I love the crisp rendering of Ganymede's unique structural features. You can practically feel its texture with your fingertips. Notice how the icy surface is littered with craters, light and dark patches, and long striations. The darker areas show older terrain, which is heavily cratered, whereas the lighter areas are comparatively younger and less cratered. But what about those long striations? We know, based on previous data, that Ganymede contains at least one vast, salty subsurface ocean beneath its icy outer layer, which some speculate could be suitable for life. Scientists think that these long structural features might reveal faults produced by tectonic movements generated by heat from the moon's iron-nickel core, but this is a subject of ongoing research. This image, taken from the same flyby on the 7th of June, shows Ganymede's Tros crater in greater detail. The reason it appears so bright is that it's covered in ice. Here is another image from the 7th of June which I find remarkable. It's a photograph of Ganymede's dark side, and it was taken by Juno's Stellar Reference Unit navigation camera. The Stellar Reference Unit was designed to keep Juno on course using starlight, which makes it ideal for photographing low light conditions. For scale, the resolution is between 600 and 900 meters per pixel. Again, notice the moon's long striations and craters, some of which are stacked on top of each other. I've seen a lot of photos of Ganymede, many of which I've covered previously, but I'm floored by the level of detail Juno was able to capture in such low light conditions. Interestingly, One of the most surprising discoveries from the mission came not from the orbiter itself, but from Hubble. Yes, that Hubble. Allow me to explain. You see, to support Juno's exploration of the Jovian moons, NASA asked Hubble to monitor Ganymede's ultraviolet signals. Ganymede has an atmosphere, albeit a very thin one, and one of NASA's goals was to find traces of oxygen they long suspected was hiding there. Nearly everyone expected to find plenty of oxygen based on previous analysis of the moon's ultraviolet emissions, but much to our surprise, Ganymede's atmosphere had vistas crisscrossed with grooves and ice ridges, and that oddly shaped dark patch just to the right of center could yield important clues as to what's behind this geological complexity. Scientists believe this darkened area shows an eruption occurring below the surface ice. The thing is, Europa's icy shell is over 10 kilometers thick. Imagine the pressure needed to penetrate so much ice. However, a new paper published by American Astronomical Society proposes a groundbreaking new theory, pardon the pun, with a different explanation.